Côte d'Ivoire is the third largest African producer of oil palm, and there is a plan to enlarge the national production. However, severe outbreaks of yellow fever and other arboviruses have been reported in Côte d'Ivoire, mainly in areas where large rainforests have been converted in oil palm monoculture. This led us to ask this question: does agricultural change may influence the ecology of Aedes mosquito in palm farming? For that, to answer this question, we assess the ecology of Aedes mosquitoes in different areas. We collected the egg, the larvae, the pupae, and adults of Aedes mosquitoes among 4 major land cover that were the rainforests, the polycultures, the oil palm monocultures, and the rural housing areas. We found that the highest Aedes species richness was found in the rainforest, while the highest Aedes abundance was observed in the polyculture. In the oil palm monoculture, we found only 4 specimens of Aedes aegypti. This picture shows that while Aedes species were lacking in oil palm monoculture, they abounded in the other land covers. This results in high biting rates in the polyculture with 22 bites per person per day, and in the rural housing area with around 5 bites per person per day. In oil palm monoculture, no Aedes female were collected. When we had a look at the biting cycle of Aedes mosquito, we found that the biting activities mostly occurred in the morning at 7 a.m. and in the afternoon around 5 p.m. How to discuss all these changes due to land use changes? We found that in the rainforest, the Aedes richness was higher. This could be due to the fact that the rainforest is able to regulate naturally the vector diversity, because the rainforests are able to provide the freeholds, the predator, the non-human primate and other wild animals, and the plant liver can provide the microbial food sources for the larvae. This explains why the diversity of Aedes mosquito were higher in these areas. Therefore, the rainforest is able to regulate diseases. Therefore, when the rainforest is converted into palm monoculture, this can lead to the loss of Aedes habitat, host, and predator. As a result, there is higher colonization of polyculture and rural housing area by Aedes vectors that lost their breeding site and host. And those areas provide a suitable environment and a container that can bleed Aedes larvae, such as the natural breeding site, the artificial breeding site, such as the tires, the water storage containers, and the discarded containers. This modifies the risk of getting yellow fever in the polyculture and in rural housing area. Because in the polyculture, the risk of getting yellow fever increased by 35 times, while in the housing area, the risk increased by 7 times compared to the rainforest. All these changes make very difficult, very complex the transmission pattern of arboviruses in this area. The vectors that were collected in the rainforest can transmit the viruses between wild animals in the rainforest. Those that were collected in the polyculture can transmit the viruses from wild animal to human working in this area, while the mosquitoes that were collected in the housing area can transmit the viruses from human to human. And this transmission usually leads to the epidemics or outbreak of yellow fever and dengue. To summarize, you can say that agricultural land use change results in the higher or the stronger colonization of polyculture and rural housing area by Aedes mosquitoes, where the risk of getting yellow fever and dengue were very high. This implies the coexistence of several arbovirus risk. And this makes very complex the vector system. Therefore, an integrated vector management should be an appropriate approach to control Aedes vectors in this area. I would like to thank our institution, Centre scientifique en Côte d'Ivoire, Université Félix Faure de Cocody in Côte d'Ivoire, the Swiss CPH, and the University of Basel in Switzerland. Thank you very much for your attention.